Hi everybody, today we're talking about Pandas. And Pandas is a Python package which enables us to easily import data, we can manipulate that data, and we can analyze that data in a simple way. But before we can use this package, we have to import it. And the industry standard is to import Pandas as PD. You will see this in basically all the tutorials on the web. But we are also going to check whether or not we have valid data entries later on. So we also import NumPy for this lecture. And when you import data, you will store data in one of two different ways, either as a series or as a data frame. And if you're storing data of one variable across several observations, then you have a series. If you store several observations across several variables across several observations, then you store it as a data frame, like a matrix, and series as a vector. So we start with series because it's easiest, but the data frame is most used. So how do we make a series? Actually, here we have a list, a string list, or a list of strings called a name list. And we just use the Pandas series method, and we pass in our name list, and we make a series variable. So in this case, if we run, let's see if we can just import this first, and we can run this, then we see that we have a list of entries here. So, and each entry or each element has an index. And we have zero-based indexing in Python. So we start at 0. So we have the first element at index 0, and the second at index 1, and so on. And the data type is object. But when it says object here, it just means that it's a string object, which means that these strings are, or these characters are actually stored as strings. And we can see this index attribute here by using the series.index attribute. And just beware, this is an attribute and not a method. So if we had written this, we would have tried to call a method, but there is no such call, no such thing as the index method for the series. So this is an attribute. So whenever you see an object and you try to access the attribute or an attribute of this object, you do not use the parentheses. But here we use the index to check where does our index start and where does it stop. So it stops at 4, but this is not including 4. So, but that was that was the series object. But we usually work with the data frame, so we can store several observations of several variables. So we have a dictionary, and we have the key value pair, and we have the key, name, and the value is this list of strings. So we also have a key value here, which is score, or the key is score, and the value is a score on the test, for example. And this is whether or not the student passed the test. And we can just make this dictionary, and from this dictionary we can make a data frame. We can make data frames from several different kinds of objects, but in this example we use this dictionary. And here we just use the Pandas data frame method, and we have to pass in some data which is stored in our dictionary. So if we run this, we see that when we print the data frame, which is stored in the df variable, we just print it by specifying the name here, we see that we have 4 observations and we have 3 different variables here. And for all the observation and variable combinations, we have some data to work with. And this is a very nice way to store data. It's called tidy data, where each column is a variable and each row is one observation. And this is very much like in Excel, but you will see that Pandas is a super powered version of Excel. So here we can call the index attribute of the data frame object, and we see that the index starts at 0 and stops at 4 and has a step of 1. You can also access the columns just to get the different column names, and here you will see that you have name, score, and pass, and they are string objects. So, and to select one of these columns, we can just place the column name within these square brackets. So if we run this, we see that at index 0, we have Oleg, index 1, we have Jenny, index 2, we have Chang, and index 3, we have Jonas. And we can change this to score, for example, and then we would get the scores. And then you will see that the data type is float, which is a decimal number. So, but we change this back to name again, and the data type is object because these are strings. You can actually select multiple columns, and you do that by placing a list between these outer brackets. So within these outer square brackets, we have a list of column names. And if we run this, we see that we return the name and the score and the observations. You can also select just one observation. Then you have to use the location method of the data frame object. And then you just specify the index of this observation. So in this case, we have at index number 3, we have Jonas. He got a 95% score and he passed the test. And you can also select several observations like this, just as with string slicing, which you have experience with previously. And then you have the anomaly here that if you put index number 2 here, you actually select index number 2. So this is to or from and to and including the endpoint here. But when you select multiple rows and like this, you do not have to use the location method. You can just pass in the selection like this. But then you have to remember that this will work just as string slicing and not include the endpoint. So this is quite important. With the Pandas library, it's super easy to import and save files. So today we're going to work with a test file or an example file, which is the Titanic.csv file. This file contains information on the passengers of the Titanic, which sank in 1914. And we have the following variables in our Titanic.csv file. So the columns are passenger ID, which is the ID of the passengers. It's the survived column. And this is a dummy variable, which is equal to either 0 or 1, 1 for survival and 0 for non-survival. And we have PC class, which is first class, second class, and third class. The name of the passenger, the gender of the passenger, and the age of the passenger. So we have two methods. The slightly cumbersome and unusual method is this method to use the open function of base Python. So we can open Titanic in read mode and put this into Titanic. And for each line in Titanic, we can print the line. And then we close the file afterwards. So if we run this, we see that we are parsed in data, and each line is a string, and the data is comma separated. So here we have the headings or the column names, the passenger ID, survived, passenger class, name, sex, and age. And here we have the observations. So this is the first observation, and you can see that this was passenger ID 1 and 0 for survived, so this person did not survive. The passenger class was 3, so he was on third class. The name was Owen Brond, and he was a male of 22 years of age. But it's fairly cumbersome to use this method to parse in data. It's much easier to, if we go down here, it's much easier to use the Pandas read CSV method, or read CSV function. And then we just pass in the function name Titanic.csv because we have this file in our in our working directory. So here we have Titanic.csv. We also have our Jupyter notebook here. So we have set this in our working directory. So if we run this, we see that nothing happens as of yet, and everything from this function is stored in the Titanic variable. So we can check the type of the Titanic variable, which is a Pandas data frame. So if we want to plot this data frame, we can just print Titanic, and we see that we have this quite nice table where we have the columns or the column names horizontally here, and we have the index vertically here, and we have that the read CSV function actually guesses that the first line in our, let's see if we can have it here, the first line in our text file actually has the column names and the column headers. So this will actually be the variable names when we start using these data or these data structures for some analysis. So here you get the top 5 observations and the bottom 5 observations. And you also get the dimensions or the size of this data frame or this data frame. So it's consisting of 6 columns and 891 rows. So, and you saw that we actually have comma separated data, and read.csv actually assumes that the data in this CSV file is comma separated. But sometimes it's semicolon separated, it's tab separated, or it's space separated, or whatever. So if, for example, we have the pipe operator here as the separator, then we can actually use the read.csv with a separator as pipe. So if we run this, we can check out what is in the Titanic underscore pipe.csv. Well, we have the exact same data, but in this case, the separator was not a comma, it was the pipe operated. Like so. Okay, but it's not only easy to import data with Pandas, it's super easy to export data as well. So if we export data to Excel, we can specify which file we are going to export this to, and then we can also, if this file does not exist, then Python will generate this file for us. So we just have to remember that we do not have this file open, because then we cannot write to it. So if we run this, then we should see here in our working directory that we now have titanic.xlsx, which is an Excel file. And this contains the entries from our data frame, because we used the toExcel method of this Pandas data frame. And of course, you can specify a separate sheet name and whether or not the index should be exported. So here we can use the toExcel method of the Titanic object, and we specify the file name and we specify the sheet name, which should be passengers. And the index should not be included, which is that this first row here should not be included. And this is because we already have something called passenger ID. So this second column here and the first column with index, they contain basically the same information. So then we can run this, and our Excel file will contain the data frame without the index. We can take a look at this file, and we just open the Titanic and .xlsx, and just wait a bit because this takes time on my computer. I have a lot of add-ins and stuff. So here we see that we have exported our data to the passengers sheet, and we have the passenger ID, survived, passenger class, the name, the gender, and the age. And we do not have the index exported. So this is how you can, well, we don't need to save that. We can close this. And this is how you can easily export data to either Excel or to a CSV file by using the toCSV method. So we can now read in the data from the Excel sheet or the Excel file, and we just specify which method we use. We use the read Excel method, and we specify the file name which is Titanic XLSX. So now we run this, and Titanic should now contain exactly the same information which we exported to Excel. And of course we have this index or column of index, which is default in the Pandas data frame. And you can also slice the data by specifying which columns you are going to look at. So in this case, we can look at, or we can import the data again, read Excel method. We specify the name of the file, but now we are using the passenger's ID, name, and survived columns. We run this, and the information we have in Titanic 2 object here, which is a data frame, which is exactly the passenger ID, survived, and name. This way, it's super easy to just import the data which you need, and you can leave the data which you do not need alone in the Excel file. Pandas is also very good for data manipulation. And here, when you have imported the data from a web link or a file, then you should do some steps with the data. For example, you should explore the data just to get a feel of what does the data actually contain, what kind of format is the data on, and if the data is on a wrong format, or you have to make some transformations of the data, then you can do that with the Pandas. And you can look for missing data. In the real world, you often have a lot of missing data. and or sometimes you have missing data in your data files, and you have to just beware of how large is this missing data problem, and what should I then do about it. And you can filter rows, and you can group by a certain variable, and you can combine data frames. And if you want to read more about these steps here, you can check out the Data Science Handbook. So, when you have imported your data, then you should explore your data. And you saw that, well, if you just write Titanic, then you get the top 5 observations, and you get the bottom 5 observations. This is just as writing head, because then you get the top 5 observations. But if you want to explore more than the top 5 observations, then you can specify an argument of the head method. For example, 9 would give you the top 9 observations here. And the tail method will give you the 5 bottom observations. And just as the previous method, you can specify the number of observations that you want to check out. And if you use the info function or info method, then you display the data types of the columns. And here we have integer, which is the passenger ID. Survived is either 0 or 1, so that's an integer. The passenger class is an integer because it's either 1, 2, or 3. Or the name is an object, because this is just stating that the name variable is stored as a string, and the sex variable, the gender, is a string. The age is a float, because this is a decimal number. So here you see that the 3 first variables, they are integers. Then you have 2 variables which are strings, and then you have the decimal number, a decimal number variable which is a float. And for the numeric columns, which is the integers and the floats, then you can use the describe method. Then you would then you will get a count, like how many observations are in this this variable or in this column. Then and you would calculate the mean, the standard deviation, the minimum, the percentiles here, and the maximum. And here you see that survived, well, it's, if we take this as an example, well, you have 891 observations. The minimum is 0, the maximum is 1, and the average is 0.38, which means that 38% of the passengers actually survived. And here you can, with these numeric variables, you can actually use the n-unique and unique methods to show the number of unique values. So here in the survived column, you have two unique values. It's 0 and it's 1. Because in our data set, we saw that, well, survived, it's a Boolean, or not a Boolean, it's a dummy variable, which is either 0 or 1. So in the survived column, you have two different unique values. And if you want to check out these unique values, then you can use the unique method of the Titanic object, and then you will get an array of 0 and 1. And the data type is, of course, integer, as we saw previously. And we can also use the function value count, which gives you a lot of information about the variable. So here you get the different unique values, and you get the count of each of them. Now that we have explored our data and gotten a certain feel of what the data looks like, and we have calculated some metrics here, but we also need to know how to transform our data or our data frame. So if you want to create new columns, it's actually quite easy. Let's say that we have this data frame here with the names, we have the scores on our test and whether or not this person passed. And we also would like to enter the name of the person. So then we can just specify what should the column be called, and we set it equal to a certain value. So here we just enter, or we just run this code, and we run or we print our data frame again, and then we see that, well, we have a column with our ages down here. We can also make a new column based on one of these previous columns, one or more of these previous columns. So then we can, as always, when we make a new column, it's like making a new variable. Then we just specify the column name within the square brackets, and this is of course a string, and we just set this equal to this value here, which takes a value from this data frame score column and divides it by 100. So this takes the score column and divides it by 100 to get a score share. So if we just run this to check what we have, and we have indeed the score column divided by 100, and it's called score share. And we can also change one of the data types here. So let's say that we do not want the score to be a decimal number. We want it to be an integer, like a counting number. So we just use the, we have to specify that our score column should now be set equal to the score column, the previous score column, as type integer. So here we use the as type function, and we turn this into an integer, which means that we should not have these decimal places here. We only have counting numbers. And in this as type function, you can use integer, or you can use float, or you can use string for that matter. So we could have turned this score column into strings, for example. And a very useful function is the apply function, because then you can apply a function to a column. So then you actually think of it as just applying a function to every single entry in a column. So here we want to calculate the length of the name entries here, and they are strings, so we can use the len function, and we apply the len function. So the argument here is actually a function, and this will give us the number of characters in each entry. And because we can, then we make a new column here called name length and set this equal to this this result, where we apply the length function to the different names here. So if we run this, then we can check out what we have got. Well, the name length is now the result of applying the len function on each of these elements in the name column. So Oleg has 4 characters, Jenny has 5, and so on. We can also drop either rows or columns, and just remember that rows are down here, so this would be 2 rows. Columns are up here, so this would be 2 columns. And if we want to drop any of these observations or these columns, then we can use the drop function. So to drop one of these rows, well, we have to specify which axis we are looking at, and by default, or in this case, axis equals 0 is the row axis, axis equal 1 is the column axis. So if we want to drop a row here, we can use the drop method of the data frame object. We drop the index 0 row, which is Oleg, and this is a row because the axis is specified as 0. If we had specified 1 here, then we would have dropped the first column. But we are dropping the first row, so then we get the result, which is which is our original data frame less the index 0 entry. But if we check our data frame again, then we see that this operation did not change our data frame. The data frame is actually intact. So if we wanted to store this, we could store this as my data frame, for example. Then this data frame would have been put into this data frame object. But if you want to change the data frame df itself, then you could specify in place equals true. So here we want to drop the first row, and we should change the original data frame, which is just called df. So here, if we run this, then we see that now the data frame object called df does not contain Oleg. So, and if we wanted to drop a column, then we could specify axis equal to 1 here. So, what if we actually drop score share in this case, because we made it, but we want to get rid of it because it contains the same information as score. And then we just drop score share. We can specify this column by name, and still we have to specify the axis equal to 1. And we put this into our new data frame, which is called df1. And df1 now contains all the rows and columns as the original data frame less the score share. But this was just removing one column. If we want to remove several columns, then we can just pass in a list to the drop function. So if we pass in a list to the drop function, then we still use the drop method of the data frame object, and we drop score share and name length. So we are dropping score share and name length from the df data frame. And we have to specify axis equals to 1 if we are removing columns. So if we take a look at this, then df1 is the same as df, but without score share and name length. So we just have name, score, pass, and age. And if we would like for the original data frame to be changed, so we are not just making a copy with some columns missing, then we can specify in place equals true. Then we do not have to set this equal to something, but we can change the data frame object called df just by specifying or using the drop method, specifying which columns should be removed, which axis, which is the column axis, and in place equals true. So if we run this and check out the original data frame, we see that the original data frame has been changed because we have removed these two columns called score share and name length. But what if you are not content with 1, 2, and 3 as the index? Maybe you have removed some observations, and then the index is 1, 2, and something else. Then you can re-specify the index here by using the data frame index function. So, or index index values, I mean. So you can specify these index by passing in a sequence, in this case a list of strings. So if we run this, we see that our index is now A, B, and C. You can also reset the index here by using the method reset index. So if we do this and we save our result in the df1 data frame variable, then we can print our new data frame, and we have index 0, 1, and 2 here, but we also have an index variable because we specified our index up there. And we can also set in place equals true and drop equals true if we want to drop the old index from the data frame. So if we do not want the old index to be there, we can drop this as well. So now we are resetting the index, and now the index is 0, 1, and 2, and we do not have the original index here as we had up here, where the original index was 1, 2, and 3, or change to A, B, and C. If you have a large data set, you would always check if your data set is complete. And if it's not complete, you would deal with missing values. And there are many ways to deal with missing values. We are not going to go through them in this video, but we are going to check how to count and find our missing data. So in this case, we are using the np.nan type from the NumPy library, and this is a float. So this nan, this is standing for not a number, and it's actually a decimal number. It's a floating point value, but it does not look like it. So let's check how this might look like. And we are making a new column in our data frame, and it contains the values Bergen, Oslo, and not a number. So in this case, we have name, score, pass, age, and city as our columns. We have Jenny, Chang, and Jonas as our observations, or the whole row here is one observation. And Jonas did not state his city. So in this case, we have a missing number, and it's not a number. And in this case, if we had a large data set of, for example, survey data, then we would like to know how many missing values do we have in our data frame. And then we can use the dataframe.isNA method, and we would get a data frame which is of the same size as our original data frame, but it would return true if the value is missing, like in our case here. But if you have a lot of data, this is quite cumbersome, and you would like to sum the not a number entries here. So then you can actually stack or combine the is and a with the sum method. So if we run this, then we get a list with the column names and the number of missing values. And if you want to drop the row or column with missing data, then you can use the drop NA function or drop NA method of the data frame object. So this is our data frame, and if we would like to drop the row here, then we could specify drop NA axis equals 0, then you would be left with this data frame. This does not change the data frame. So if we just print our data frame again, then you see that the data frame has not been changed. So either you have to save this result as a new variable, or you can specify the in place option as we did up here. But I want to continue using our, let's see here, where was we? Where were we? We were here, and I would I would like to use the whole data frame here, but now drop the city column. So if we drop an A based on axis equals to 1, which is the column axis, then we drop the city. But here we drop every single column which has one or more, not a number in it. So yeah, so we can fill the not a number with another string if we would like so. So in this case, we would like to fill we would like to exchange the not a number with the string missing. So then we can use the fill NA method, and we see here that we, instead of not a number, we have a string instead. Or we can, instead of using the fill NA, we can use the replace method of the data frame object, and we search for these numpy not a number entries, and we supply what we are going to replace this first value with, which would give you the exact same result. And you can also select a subset of the rows and columns in the data frame based on some conditions. And the condition has to be either true or false, which makes it a Boolean expression. So in this case, we have the scores from our data frame. So if we just type A, enter and df to check what we have here. So in this case, we have scores here of 58, 79, 95, and in this case, we can make a list of these scores, but entering true or false depending on this condition here, this Boolean expression. So this would be either true or false based on the entries in this column. So if we run this, and store the result in this list. Then we can run it, and we have that entry index number 0, it's false, and the index number 1 is true, and index number 2 is also true. So index number 2 is true because the score here is above 95. And so this these Boolean values, they can be used to filter our data frame. So if we specify our data frame again, or print our data frame again, so we know what we are working with, then we can specify the rows here, and we are going to print remember that above 75 contains false, true, and true, and then we are going to print only those observations or rows which are specified by true, which would be Chang and Jonas. But this step here to make a separate list with Boolean values, it's quite cumbersome often. So what we can do is to put the test directly into the call for the data frame. So here you would only get the entries where score is above 75. You can also have the scores for entries less than 75 or equal to 75, but there are no entries equal to 75. So if we just take a look at the entries with a score of above 75, then we can also combine this with filtering these rows. This is filtering rows, and we can also combine this with column selection. And when you want to select specified columns, you can put that in brackets or in square brackets after the call for the data frame. So here we just want the names of or the name column for scores above 75. And here, instead of greater than or equal to, or actually equal to, I should have done this, not the single equal as I did previously. That was my mistake. But you can also have a not equal to, for example. So, but we just changed this back to greater than. And then this, if we have this data frame again, we have not changed it in any way. We have just taken a look at some subsets of this data frame. But if we have this data frame again, then we can provide a, for example, name list. In this case, Chang and Jonas, or we can, for example, check out Chang and Jenny. Then we can put this in the name list, and we can actually pass this in as a membership operator. And then we specify data frame name, which is the column, is in name list. So is in name list will give you a list which is true or false based on these values here. So if the values of the name list is in the column entries of name, then it will be printed. So now we are printing Jenny and Chang. And we can also filter on several conditions. For example, we have condition 1 here, data frame age is less than 21, and condition 2 contains data frame pass is equal to yes. So if we run this, and if we just check out the condition here, it contains either true or false. So it's true for those entries where age is less than 21, and it's false for those with age greater than 22. And the same for condition 2. It contains false for pass not equal to yes, and true for true if this statement is true for the entry. But when you add several conditions, you have to use these parentheses around the conditions, otherwise you will get an error message. So if we remove these, then this should not work, but in this case it actually did. I think it's when you do this, you have to have these parentheses. And if, yeah, so here you would have to add the parentheses if you have this, have these Boolean expressions directly in the slicing of the data frame. And of course, you have this AND operator, and this will only print the instances where this is true and this is true. You can also have the OR operator, which is this bar, and then you would print all the conditions for which this is true or this is true, or both of them are true. So this is everything for today. For the next lecture, we are going to look more into how to use Pandas.